Okay, this lesson is on logarithms. A logarithm is actually just an exponent. When you're trying to evaluate a logarithm, what you're trying to do is find an exponent. Keep that in mind. Y equals log base a of x. This means x equals a to the y. The most important thing to know how to do when it comes to logarithms is how to switch from one form to the other. This is called log form, and this is called exponent form, or exponential form. Notice that this number here is lowered. It's the base, and it has to be positive, and can't be 1 exactly, but it has to be a positive number other than 1. We're going to practice switching from log form to exponent form and back and forth. For example, let's say I have 2 cubed equals 8. Okay, that's currently in exponent form. The 8 is the x here, the 2 is the a, and the 3 is the y. And so if I write it in log form, then the 3 is here, log, the base is the 2, so it's lowered. We write it a little subscripted like that, log base 2 of 8. And so I just did a little bit of substitution here on this, and I got 3 equals log base 2 of 8, and that's what it would be in log form. Here's another one. 4 squared equals 16. In log form, that would be 2 equals the log. Now, as I said before, a logarithm is just an exponent. So a good thing to just check here is, you see, the 3 is the exponent, and the 3 equals the logarithm. The exponent is equal to the log. Here, the exponent is 2. The 2 equals the logarithm. The logarithm has to equal the exponent. The base is 4 and then of 16. And so we'd read that as the log base 4 of 16 equals 2. Here's another one. 5 to the 1/2 power is the square root of 5. That's an exponent form. In log form, that would be the exponent is 1/2 log base 5 of square root 5, and we've written it in logarithm form. Now we also need to be able to go in the other direction. If I give you a logarithm, in log form, you need to be able to put it in exponent form. For example, the log base 5 of 25 equals 2. This, in exponent form, has a base of 5, and students find it helpful to use the arrows here. 5 squared equals 25. That's what it is in exponent form. 5 to the 2nd power is 25. Here's another one. Log base 8 of 8 equals 1. If I write that in exponent form, that's 8 to the 1st power equals 8. 8 to the 1st power equals 8. And here's one more. Log base 5 of 1 equals 0. If I write that in exponent form, it's 5 to the 0 power equals 1. Okay, make sure that you understand how to go from log form to exponent form and the other direction as well. It's perhaps the most important thing there is in dealing with logarithms. Just knowing how to switch from one form to the other will allow you to solve some logarithmic equations already. For example, solve log base 3 of x equals 2. To solve this equation for x, all I'm going to do is take this equation that's in log form basically and write it in exponent form. In exponent form, it's 3 squared, 3 to the second power equals x. 3 squared equals x, and so x is equal to 9. The solution is 9. Here's another one. Log base 2 of x minus 5 equals 0. We write it in exponent form. 2 to the 0 power is equal to, let's fix that, x minus 5. 2 to the 0 power is equal to 1. 1 equals x minus 5. And if I solve that for x, I get x equals 6 as my answer. Okay, we're solving these log equations simply by putting them in exponent form. Here's one more. The log base x of 36 equals 2. Writing that in exponent form, we end up with x squared equals 36. If x squared equals 36, then I can solve for x by taking the square root, plus or minus square root of 36, plus or minus 6. However, as we mentioned earlier, the base number up here, a, must be positive. And since x here represents the base, I can only use the positive value, x equals positive 6. No negative bases are allowed. Okay, moving on. Evaluate, or simplify, find the value. Log base 2 of 8. Now, this logarithm is equal to an exponent. We're trying to find an exponent, and the exponent that we're trying to find is this. The base 2 to what exponent will give us 8? 2 to what exponent gives us 8? And that answer would be 3. 2 cubed is 8. And so this logarithm is equal to 3. Or you can just write there, it equals 3. Because 2 cubed is 8. Here's another one. Log base 4 of 16. Okay, so what it's asking is the base 4 to what exponent will give us 16? And that would be a 2. 4 squared is 16, and so this logarithm equals 2. Log base 25 of 5. Okay, this logarithm is saying 25 to what exponent equals 5. Now, the square root of 25 is 5, and so that has to be a 1/2. 25 to the 1/2 power is equal to 5, and so this is a 1/2. Log base 7 of 7. This logarithm is asking 7 to what exponent will give us 7? And that would be to the first power. 7 to the 1 equals 7. So this logarithm equals 1. Log base 4 of 1. Okay, this logarithm is saying 4 to what exponent will give us 1? And that would be 4 to the 0 gives us 1. And so this logarithm is equal to 0. Log base, let's see which one we got here. Log base 5 of square root 5. All right, this one is asking 5 to what exponent will give us the square root of 5. And we saw one similar to this. That's 1/2 power. 5 to the 1/2 power is the same as the square root 5. So this is a 1/2. Okay. Now, if we write log of 100, if I just write in log and I don't put a base, this is called a common log. And common logs are always base 10. So the log of 100 really means log base 10 of 100. It's called a common log, and that's the log button that's on calculators. The calculator log button does not do base 2 or 4 or 5. It only does base 10. So this one is asking 10 to what exponent gives us 100. And that would be 2. 10 squared is 100. And so this logarithm is equal to 2. Okay, let's do a few more here. Log base 10 of 1/10. Oh, well, if I don't write the base in, we know that that's a common log, and so the base would be 10. Common log. So this one is asking 10 to what exponent gives me 1/10. And the exponent that would do that would be -1. 10 to the -1 is 1/10. So this equals -1. Now, the other type of logarithm that we have on our calculator besides a common log is base 10. We also have a natural log, what's called a natural log. And that is the button LN, standing for natural log. And it is a logarithm, it is base E. Now E, the number E, is about 2.71828. It's a number that occurs a lot in upper level mathematics, a very important number. It even has its own, if you look above the natural log key, you'll probably see an e to the x there. Okay, so for all that you need to know right now for E is that it's a number, it's about 2.71828. So if I ask what's the natural log of E, because it's natural log we know the base is E, and so this logarithm is asking E to what power equals E, and that would be a 1. The natural log of E is 1. It's a good thing to remember. Likewise, the common log of 10. The base is 10, so 10 to what exponent gives us 10? That is also equal to 1. So two good equations here to remember. The natural log of E is 1, and the common log of 10 is also 1. Now, the change of base formula up here is used to convert from one base to another base that your calculator can handle, usually base 10. For example, round to 2 decimal places. Let's say we want to know what the log base 3 of 70 is. Now I don't know what 3 to what power gives me 70. It's some decimal. I'm not sure what it is. I can estimate it. I know that 3, if I raise it to the 4th power, gives me 81. That's a little too much. It's a little past 70. 3 cubed is only 27. So I know that this exponent is somewhere between, it's got to be somewhere between 3 and 4. Not sure where, but it's got to be between 3 and 4 somewhere. Now, the calculator will not do base 3, and so I have to use the change of base formula up here, and it's very easy to use. All it says there is that the log base 3 of 70 is equal to the common log of 70 divided by the common log of 3. We divide like that. You can type that into your calculator, and if I do that right now, the log of 70 divided by the log of 3 rounded to 2 decimal places is about 3.87. And just as we suspect, it's between 3 and 4. Change of base formula. Here's another example of that. Suppose we want to estimate the log base 1/2 of 50. According to the change of base formula, I write that as the common log of 50 divided by the common log of 1/2. I'll write that as 0.5 there. We can now type that into our calculator. Log 50 divided by log 0.5 equals negative 5.64. So there's our estimate right there. That's how we use the change of base formula. Okay. Excuse me. Let's graph a log function. F of x equals log base 2 of x. So we're going to graph. We'll make a table of points. Let's start with 0. If I plug in 0 for x, I get the log base 2 of 0. Now, what that means is, as we've been talking about, 2 to what power gives me 0? Now, if you think about that, there's no way you can make 2 to an exponent equal 0. It's not possible. And so this is undefined. You can't take the log of 0. You can't take the log of 0. So there's nothing at 0. As a matter of fact, if I tried negative numbers as well, for instance negative 1, I can't take the log base 2 of negative 1 either, because 2 to what power would give me negative 1? There's no exponent that's going to do that, and so this is also undefined. So you can't take the log of 0, you can't take the log of a negative number. What's inside the logarithm must be strictly positive. So I guess here I will start at 1. Okay, now the log base 2 of 1, that I can work out. 2 to what power gives me 1? I know that that is a 0. So 1 comma 0 is on the graph. 1 0 is right here. Let's try 2. Plug in a 2 for x. The log base 2 of 2. 2 to what power gives me 2? That is a 1. So our graph goes through the ordered pair 2, 1. Right there, 2, 1. I'd try 3, but then I need a decimal. I'm going to skip to 4. If x is 4, log base 2 of 4. 2 to what power gives me 4? And that is a 2. So my graph also goes through the ordered pair 4, 2, which is right there, 4, 2. And so it's curving up like this, and it is heading up, but very slowly. What is it doing on the left side? Well, it doesn't go to the negative numbers, as we talked about. You can't plug in a negative number. Nothing's there. However, if I try, let's say, 1/2, if I plug 1/2 in, log base 2 1/2 means 2 to what power equals 1/2? And that would be a negative 1. So a logarithm can equal a negative number, but you just can't take the log of a negative number. You can't have a negative number in here. So this is the ordered pair 1/2 -1, which is right about there. And what logarithm curves do is they curve downward, they follow the y-axis, but they never hit it or actually cross over it. They always stay on the right side. And basically all log functions look like this. They all go through 1, 0 here. And in this case, the domain, the x values, everything is from here over. So the domain is from 0 to infinity. Notice that it does not include 0 because you can't take the log of 0. It's got to be strictly positive. And the range, notice that it goes down along the y-axis and it keeps heading upward as well. It goes up very slowly but will continue upward, and so the range is actually all real numbers, negative infinity to positive infinity. Now this is the basic graph of a logarithmic function. That ends the lesson.